Thanks for coming out, and thanks for Paradigma for hosting me again. And I guess they didn't learn their lesson after the last time they let me talk. So I thought I'd tell a little bit of a story about how this talk came to be. I guess it was in the spring, April or something, and I was trying to come up with a good talk to give at Google I/O. I had just come out with a book on BigQuery, and I kind of wanted to be able to pitch the book a little bit. And I was also in the process of planning a trip to Brazil for the World Cup. And I thought, well, maybe I could combine the two together. So decided to try to predict the winners of the World Cup. Sounds easy, maybe. I know a little bit about machine learning. I know a little bit about soccer, but I'd never tried to do this kind of prediction before. So it was kind of a crash course in sort of learning how to use various machine learning tools, and in combination with the Google Cloud Platform. But if you fast forward a couple of months during the World Cup, Felipe Hoffa, who's a DevRel engineer on BigQuery, and actually Felipe is giving a talk tomorrow about genomics in BigQuery, so I highly recommend that. But Felipe and I, just discussed machine learning in general and World Cup prediction, and we made on stage 8 predictions about who was going to win the round of 16 in the World Cup. Unfortunately, Spain had already been eliminated. I was upset. You can see I'm a Spain fan. Maybe you guys were a little bit more upset. That's possible. But so we made eight live predictions on stage. All 8 of those predictions came true. Then we made some additional predictions for the following rounds. We missed one game of the quarterfinals, the France-Germany game. I'll describe a little bit about why we missed that in a few minutes. We got both semifinal games right, and we got the final right. We missed the third place game, but so overall we were 14 for 16, which was I think reasonably good, considering we were not machine learning experts, and so that was kind of exciting. But the thing that I'm actually most proud about, even more so than getting 14 out of 16 games correctly, is that when we were done, we open sourced the models that we used, and we released them on GitHub. And so Google Cloud Platform IPython soccer predictions has essentially everything you need to run the same machine learning that we did. So on one hand, I don't even need to talk anymore. You guys could just all give this a try. But just in case, I'll sort of walk through what we did, how we did it. And at any time, please feel free to stop me and ask questions. If something doesn't make sense, or I'm hand waving and skipping something, feel free to just break in and ask whatever questions you have. One thing I do want to mention is that I don't have a better slide for this, but Google is offering a free cloud platform, $500 in cloud platform credits to all attendees of Big Data Spain. So all you need to do to get that is go to this URL here and enter the code, which is Big Data Spain, and you'll get $500 to play with on whatever you want in Google Cloud, which is way more than enough to sort of do what we're going to show in this example. This example probably would cost less than $1, as long as you didn't forget your virtual machines and leave them up for a month, which I've been known to do. So the tools that we're using, the whole point of this was to showcase the Google Cloud Platform and how you can use it for machine learning and scientific data applications. So we're using BigQuery, which is where we do our feature selection. So we have a reasonably large data set, which I'll describe in a minute, and we build the features in BigQuery. We run IPython, but to run IPython, we run the actual sort of the code behind IPython is running on a Google Compute Engine instance, and we use Docker to in one touch, one step to create that IPython instance. And we're using Google Cloud Storage as well, which is how we get sort of data up into the cloud and back down. There's we also use some open source tools. I mentioned IPython. We have sort of a special version of IPython that we're using that's integrating with makes it easier to integrate with the Google Cloud Platform and takes care of authentication, authorization, those kinds of nice things. And we also use, hi Thomas. We also use pandas, scientific Python, scikit-learn, stats models, and sort of a bunch of other sort of best-of-breed scientific computing in Python. So we don't, like, R is sort of the alternative, and we decided that that there was better integration in IPython and using the Python stack. So what data that we have? So when you're doing machine learning, I sort of like to use a Donald Rumsfeld quote. Not my favorite person, but but he was a good source of quotes. He said, "You don't go to war with the army you want; you go to war with the army you have." And it's like you don't go to war with the data you want; you go to war with the data you have. So the data that we have really constrained what we can do. Luckily, we had this amazing data set from Opta, and they're really the pinnacle of sports data providers. They have a ridiculous amount of touch-by-touch data for every single game in the Spanish La Liga for 2 years, the English Premier League for 2 years, and because we're Americans, we also included the MLS for the last 2 years. We also had we were getting live-streamed updates for the World Cup, and we had a previous World Cup that we could use to sort of to test things out on. So to give an idea of what is in this data set, you could, this is a spreadsheet that describes just some of the factors that we can see, whether it was an attacking pass, whether it was a disallowed goal, assists, the length of passes, the angles of passes, where the goalkeeper was during shots, and I'll kind of give an example of this. So this is BigQuery, and this is the table that we had loaded up in BigQuery, and we were constantly refreshing this as games were coming in. So we've got over 4.5 million pieces of data, 902 megabytes, which is not quite big data, but I mean it's one of the nice things about these approaches is they'll scale to virtually any size data. So we have, for each event, we have when it happened in the game, what happened, which player was involved, and where it happened on the field. So to give an example, I don't know if you remember Robin van Persie's first amazing header that was from the top of the 18. So this sort of gives, let's see, here's an example of the data that we have on that header. So we have where the goalkeeper was. He was in the Y coordinates. He was right in the center of the goal. Actually, I need to rerun this query. Too many windows. Okay. So we have where Robin van Persie was when he scored the goal. He was. So these are coordinates based on if it was a 100-meter field. He was right in the center, and that was who scored. And then we have information about extra information about the goal, such as where the keeper was, the fact that it was in the upper right corner, that it was. You also have that the keeper was 4.2 meters out. So I don't know. Did Casillas get cut off his line? Maybe, maybe not. And that it was a lob. So we have lots of data, lots of things that we can mine to figure out just what things are going to make a team win in football. So I'll call it soccer a lot. As an American, I try to say football, but to me, football is something with giant guys with pads beating each other senseless. So excuse me if I say soccer too much. Let's see. Okay, so I'll walk through the notebook, the IPython notebook that we used. if you guys heard Paco's keynote this morning, he was talking about how great notebooks are and they're shareable. So this notebook is shared on in GitHub, and there's also a notebook viewer that you can access directly from the web. And so I'm just going to go through and highlight a couple features from here. So one thing that I want to show is that with sort of this Google Cloud Platform integration, you don't need to do any authorization. All I did was start this instance from a I just ran this Data Studio IPython shell script, and it launched the Compute Engine instance, launched IPython in a Docker container, did all the auth magic and keys that needed to be set up, and started a web server locally on the machine. So I can right away get started with running BigQuery queries, which is what this will do here, and it pulls some metadata back. Right now, it's just showing the size of the table, which we saw from the BigQuery web UI. Another nice feature that this has is uses IPython magics, and IPython magics lets you just write any BigQuery SQL statement you want in the cell, and when you run it, it will run the query and output the results. You could also save the results if you want to hold on to them. So this is the data that we have about every game. So I'll describe what the features are in a few minutes, but we've got sort of a number of things, and these are the things that we used to predict the World Cup. So the whether the number of shots that a team had on target per minute. We built an expected goal statistic that took into account where previous shots had been made and how far away they were to say, well, how many goals should they have scored? Because in soccer, there's a problem that the goal scoring is so low that it's hard to know. It's hard to make meaningful statistical conclusions because you have these rare events. And so I'll describe these things in a little bit more detail in a minute. So the other thing that we did is, so obviously you can't predict the outcome of, you don't want to predict the outcome of a game by how many passes there were in that game, because that's not much of a prediction. So we look to predict game X. We look at the previous 3 games that team had played. So this history size here lets us set a window of how many games we want to look back. And the advantage of using 3 is that when we did our talk originally, there had been it was after the group phase, so there had been exactly 3 games in that World Cup. So we had seen each team play 3 times. But we built the model. We didn't build the model on the World Cup. We built the model on looking at club data, and we looked at across several different clubs and several different leagues with the assumption that would sort of give us a variety of data and different types of players. So here we're actually running the BigQuery query to get the features, and then I'll skip down here to show what this looks like for one game. So this game is Argentina versus Netherlands in the semifinal, and so the team that we're looking at is the Netherlands, and we have the average number of goals that they've scored in the last 3 games, average points. So points is 0 for a loss, 1 for a draw, 3 for a win. The number of missed passes per minute, cards, corner kicks, expected goals I described before, and then also information about the opposing team. So how many goals had the Netherlands let in? Let their opponents score. How many cards had their opponents had? So these pass statistics. So we have pass 70 and pass 80. Those are how many completed passes they make per minute in various parts of the field. And then the pass to pass completion ratio. So I wouldn't necessarily usually go into such detail, but one of the things I'd like to do is at the end of this talk, if we have some time, I'm going to let you guys suggest some additional features. So we saw all that data that we have. You guys might have some other ideas of what things could influence the outcome, and we can rerun the models with those things added. So another thing in machine learning that's really key is you've got to know your data. And there were a number of cases where we didn't understand our data well enough, and we had data bugs, and that caused it to be more difficult to predict. And so here's just a crosstab calculation of how does goal scoring correlate with lost ties and wins. And this one in particular let us see that we were counting goals in extra time. We were counting goals that in games that ended in penalty kicks. So we saw that, for example, there were teams that had 7 or 8 goals and they lost, and that didn't make sense because that doesn't usually happen in normal play. But when we looked at the games in detail, we saw that those actually were games that ended in PKs. So the general steps of machine learning is you pick your features, and the features are generally just wild guesses about what you think is going to be important. Usually when you're doing feature engineering, it's more important to try everything than it is to try only the important things. And we're going to let our modeling process pull out only the things that are interesting. But then you train a model. So to train a model, you take historical data where you know the outcome, and you build a model based on that historical data. And so here we have we call out to some code that trains and cross-validates the model. In a minute, I'll go into what that code is actually doing. But one of the things that we get out of this is the R² number. R² is essentially a goodness of fit number. So higher is better. And so as we're trying different things, as we're training, we can see how close our model matches to the type of machine learning we're doing, which is logistic regression. One nice feature of logistic regression is that it lets you see how important various features are. So we can actually inspect this model, and we can see what actually made a difference. So what things define whether a team is going to win. So the first one probably isn't surprising to anyone, that home team advantage is massively important in soccer. So the home team wins a lot more than the away team. I guess that's why home goals count double in two-legged games. So other things that were important, how well you pass in the opponent's third of the field, how many average goals you have, how many shots you have, how many points you have. So the way we did our logistic regression, it'll drop out things that seem like they don't actually have much impact. So the things that were dropped were how many fouls other teams committed against you, how many cards you got. So expected goals didn't show up on this one. It's possible that it showed up in something that correlated with that. And then we have negative features. And negative features are the things that make you less likely to win. And so there's a little bit of a strange nomenclature here. We have OPP, which is the opposition of the current game, and then OP is the opposition in the previous games. So if your opposition had played against teams that passed really well, then that's actually means that you're less likely to win, because essentially it means that the team you're playing against is better. If the opposing team passes really well in your third of in the attacking third of the field, then that's also bad for you. So once we've built the model, then you turn the model into predictions. And so it's pretty straightforward to apply a logistic regression model to additional games, as long as you have access to the same features. So what we did is when we built the model, we split out 40% of the games, and we save those on the side. And what we use those for is we use those to validate that the model makes sense. So let's look at some of the things that we got right. Another thing is that it's very often that you think you're doing well, and then you look at the actual things that you're predicting, and sometimes they don't make sense, and that often means you have a bug in your process. So here we predicted Arsenal over Newcastle United. That makes sense. Manchester City over Reading, Arsenal over Queen Park Rangers, Liverpool over Newcastle United. So these predictions all kind of make sense. What about the things we got wrong? Let's see. Well, we predicted Liverpool would beat Southampton. I would usually pick Liverpool over Southampton. That seems like it makes sense. So these seem a little bit. Maybe I wouldn't have ever picked Wigan to win, but the other ones look reasonably plausible. So you don't want to just sort of sample the things that you predicted. You want to have a way of actually measuring how well did we do. So we compute a couple of statistics. The first one, the one you'd expect would be accuracy. And the problem about accuracy is it's very sensitive to the underlying distribution. If you're predicting something very rare, you may have very low accuracy, but you may actually be making very good predictions. So we use lift, which means how much better are you doing than random. So here we're saying we're doing 45% better than just random chance. And we also compute this curve, which is called the ROC curve, and it's a strange name that derives from World War II, and they were using the same techniques to find U-boats via signal detection. But essentially what it is it plots, if you sort all your predictions based on how confident you are, and you start picking out the ones you're most confident in, and every time you get it right, you take a step up. Every time you get it wrong, you take a step to the right. You will the better you're doing, the faster it goes up, the higher probability the ones you're really sure about are actually right, and the further this curve bends away from the center line, the better you're doing. So perfect would be if this blue line was basically straight up, and completely random would be if it was just straight from the bottom corner to the top corner. Because it's a little bit hard to measure how well you did based on just sort of looking at a curve. We also compute the area under this curve, called the AUC, which is so about 75% here. So we also added one thing that was I thought was kind of cool, and this came about. I was talking to a coworker. He doesn't do anything with machine learning at work. But he was interested in what we were doing, and he described his son plays pee-wee football, and pee-wee football is usually 10-year-old kids, and this is American football. They dress up in the pads and they hit each other, and it's usually kind of funny to see these little kids beating on each other. Maybe it's not funny. It's sad, but anyway, he was really interested in how his son's pee-wee football team was doing, so he built machine learning models to figure out what are the good teams that they have to worry about. Putting a lot of effort into something that maybe not that many people care too much about, but it actually provided some great insight into what we were doing. So what we're doing is we're building a power model. So one of the important things in a game is who's playing, which teams are playing. The fact that Manchester United is playing is a pretty good signal that team is going to win. The fact that Wigan United or Wigan Athletic is not quite as good also sends a signal perhaps in the other direction. So a power model is essentially a way to collect all the data we have about which teams won, which teams lost against each other, and come up with basically how important is it that Manchester United playing is if you're trying to figure out whether Team A is going to beat Team B. And we use the exact same type of process we do in the regular machine learning is we're building a logistic regression model, and we're building a logistic regression model where the features are basically which teams are playing. So most of the features will be 0 because that team wasn't playing. One team will be +1, and the other team will be -1. Doesn't matter which one is which. And then basically the thing we're trying to predict is the outcome, whether the team's won or not. And you crunch the numbers, and it turns out that the logistic regression factors, the feature factors, will give you an idea of which teams were better than the others. So if you look, here is of the 3 leagues that we looked at. So here are the sort of the overall rankings, and we did the rankings of the different leagues separately. So it doesn't necessarily mean that the Portland Timbers are just as good as Manchester United. We kind of we threw them all into one ranking. But we see that sort of at the top of the pile is Manchester United and Manchester City, Real Madrid as well. You guys probably happy to hear that. Atletico Madrid is also one of the top ones, and then at the bottom we have Real Zaragoza, Deportivo, Mallorca, etc. So these kind of give us a way to, and so what we do is we turn these into a feature themselves. So we take these coefficients and we put them back into our machine learning model and add them as another feature. And so this is the outcome of running the same regression, just with the addition of the power model. So the green line is the line we saw in the previous chart. The blue line is how we do with the power model. And we can see that our lift has gone up from 45% to 56%. Our AUC has gone up to almost 0.8. And we can see that power is actually quite an important feature here. So, our goal wasn't to predict La Liga games. Our goal was to predict the World Cup. So we wanted to be able to then apply those to the World Cup. So we built the same features as for the World Cup, and we built the same power ranking, and we can see what the power rankings showed up. So we have Germany and the Netherlands at the top, and Argentina. Spain did surprisingly well considering the outcome of that tournament. And then at the bottom, USA was not deemed to be very powerful by our rankings. And so since we had teams from multiple World Cups, there were teams that were not actually in this World Cup as well. So then we want to predict the World Cup. And so sort of one caveat, a bunch of things had changed, including when we did these originally, we were doing round by round. So we would change the window every time we predicted the next round, because when we were predicting the round of 16, we knew we'd seen 3 games for each team. But when we were predicting the quarterfinals, we'd seen 4 games. The finals, by the finals, we'd seen 6 games for each team. So these don't necessarily match up with what we did, but here's what we predicted. We expected Argentina to beat the Netherlands, and here we say this was a draw because it was a draw after 90 minutes. But Argentina did go on to win. We do have Brazil over Germany, and that's a little bit disturbing. But we had Netherlands beating Costa Rica. So we have pretty much all of these were correct, except I guess our American nationalism got in the way somehow. This computer was designed in the U.S., so it wouldn't let the U.S. Be predicted not to win. But so when we actually did these, the results were different. We did have that one picked correctly, and some of these actually go back even further. from the previous World Cup. So now I'm going to show what the code actually looks like for this. So because we wanted the notebook to look somewhat clean and easy to understand. We moved a lot of the code into these accompanying files. So I'll just quickly take a look at what some of these files have. So match stats is computing a bunch of statistics about each game. The goal is, so we have a couple of functions here that basically says get features, match games table, the match goals table pulls the features of a number of goals in a game out, and then the match games pulls all the features we care about, all the raw statistics. Then we compute the features on top of them. But to just show like what some of these look like, let me see if I can find something interesting. So one of the patterns that we tend to do a lot is we run a query, and that pulls out interesting things that we need, and then we either wrap it in an outer query that then adds more things or does aggregations, or we'll join it by some additional data. So we may have several 8 or 10 queries that we all join together by on the team ID and match ID, and each one of those queries is computing a particular type of statistics. So we compute the so here's where we compute the passes, the bad passes, the number of fouls, the number of shots and cards, etc. Then we sum those up in an outer query. We compute the number of shots on target, etc. And then we also, so here's an interesting thing. We also divide by length. Which is actually sort of how many of these things that we have. So one of the reasons that we got the France-Germany game wrong was because we had erroneously ingested the same game twice, and we were just computing the total number of passes per game. And when we added the same game twice. Oh well, 5 minutes left. We added the same game twice. We actually thought that France had done much better than they actually had. So that's just something to. So when you're writing code, it's easy to write unit tests and have a pretty good idea of what success looks like and what failure looks like. When you're doing data analysis or data manipulation, if you have data bugs or data interpretation bugs, it can be really difficult to figure out why you have messed up in that way. Let's see, 5 minutes. We may not have enough time to. Maybe we can give it a try. So, does anybody have ideas for other features to add to the model that we can try to hack in a couple minutes? Anyone? Yes.
Need to win. You don't need to win your first game to stay in the tournament, but if you're in the finals, you do need to win.
That's an excellent. So the need to win is an excellent one. I would love to add that, but that's probably going to be really difficult to do just from these raw statistics. So one thing I thought about adding was injuries. So Brazil suffered a pretty nasty injury in the final game, and sorry, not in the final game, in the quarterfinals, or to one of their superstars. And that actually wasn't captured in our model. So let's see if we can figure out how to add this to the model. So we have injury is one of these events we have. So it's event ID 41. All right. And please let me know if I screw anything up here. Outcome ID, and we don't need this. it should be okay for that one. So this is the feature calculation. So there's a lot of places where you have to do this, and if I'd had more time, I probably would have cleaned it up so that we could compose these things better. But when you're trying to predict things that are happening at a particular date, you can't say no. We'll just like delay the World Cup a little bit while I figure out how to get this stuff to work. And there are a lot of these. I'm probably running out of time. Okay. Now we're uploading our changes into the cloud. And while that's going, I will reload the match stats. And awesome. So this is trying to pull in the latest copy and bring it into the notebook. And come on. There we go. And I know we're running out of time, but we're almost there. So let's see. Alrighty. And now it's running queries, and didn't seem to screw up. Oh, all right. Well, sorry about that, guys. But anyway, you get the idea. Maybe afterwards I'll send out a tweet about whether injuries would have helped our Brazil prediction. But anyway, that's all I have for the talk. Let's see, just make sure yes. Does anybody have any further questions for me?
Did you win money on it?
Did I win money on it? That's a really good question. I did not bet. I had my reputation at stake on whether my predictions were going to be correct or not. So that was way more stress than I needed. I didn't even think about betting. But anybody? Great. Well, thanks very much. Appreciate it.